Okay, so screencast on solution stoichiometry. The essential question that we're going to address is how can we quantify chemical reactions that occur in solution? And by the end, hopefully, of this screencast, you will be able to solve solution stoichiometry problems. All right, so let's go back to stoichiometry and look at this warm-up and think about the steps that you would need to take to solve the following problem. Given that balanced chemical equation, how many grams of aluminum are required to react with 9.12 grams of hydrochloric acid? Pause the screencast, think about it. Okay, and we're back. So how would we solve it? Well, first thing we would do is we would convert the grams of hydrochloric to moles. And then using the mole ratio, convert the moles of hydrochloric to moles of aluminum. For every 6 moles of hydrochloric acid, I need 2 moles of aluminum to react with it. So then when I get to the moles, then I can go back to the grams. Okay, so let's do that. I had 9.12 grams of hydrochloric acid. Oops. Times grams hydrochloric in 1 mole, 36.46. That's hydrochloric. There's a point there. Times, for every 6 moles hydrochloric, I get 2 moles, or I need 2 moles of aluminum to react with it. And for every 1 mole of aluminum, there are 26.92 grams of aluminum. Solving for that, I should get 9.24 grams of aluminum needed. Now that is just a review of stoichiometry that we've been doing. Again, molar mass, mole ratio, molar mass goes from grams of one reactant relating to different reactants from a mole ratio, and then going back to the grams of the other reactant. Now, how do we apply solutions to this? Well, we'll be given a problem like this. How many grams of aluminum are required to react with 125 milliliters of a 2 molar hydrochloric solution? Well, how can I use volume and molarity concentration to get to a mole ratio? Because stoichiometry all hinges on getting to a mole ratio to relate two different things. Think about it, and then pause it if you need to. Well, if I take that concentration in molarity and multiply by volume, as long as the molarity and the volume is for the same solution, I can get moles. So again, if I can get moles of a reactant or a product from the molarity and the volume, then I can get to a mole ratio and I can convert to anything else in that problem. So let's see what that looks like for this problem. Okay. So, how many grams of aluminum are required to react with 125 milliliters of a 2 molar hydrochloric solution? Well, I take my 125 milliliters. I know that this molarity is moles per liter, so I have to convert those milliliters to liters. There's 1,000 milliliters in 1 liter times the 2.00 moles hydrochloric in 1 liter times, for every 6 moles of HCl, I have 2 moles of aluminum. That's the mole ratio from the balanced chemical equation. Then moles of aluminum, grams of aluminum, that's 26.92, molar mass again. And I end up with 2.42 grams of aluminum needed. Okay, so let's look at another example. Using the same equation, Question is, how many liters of a 1.5 molar hydrochloric solution are required to produce 2.50 grams of hydrogen gas? Okay. So really, if you think about this problem, okay, wants to know how many liters of this concentrated solution. Well, keep in mind that volume times the molarity is going to equal the moles. So we're looking for this. If I can get to moles, then using this molarity, I can get to the volume needed of that reactant. Okay, because volume is really just going to be moles times moles in 1 liter. That's the concentration. This is the molarity term. All right, so I'm given 2.5 grams of hydrogen gas. Can I take those grams to moles? Oh, sure. So let's work it through. 2.50 grams of hydrogen gas times grams of hydrogen in 1 mole. Remembering that that's a diatomic, 2.2, that's moles of hydrogen. Then from the balanced chemical equation, 3 moles of hydrogen for every 6 moles of hydrochloric times, here's where this molarity comes into play. I have 1.50 moles of hydrochloric for every 1 liter of solution. Then, oh, it asks for liters, so I don't even have to convert to milliliters. Okay, so if I do that, I have 2.50 divided by 2.02 times 6 divided by 3 divided by 1.5. I should get 1.65 liters. 3 significant figures because there's 3 significant figures there and also 3 there, so in the given. Okay. There'll be another screencast running through an additional 2 problems.